two matrix. So you will get 1 into 1 plus 0 into this one. So you will get 1, then 1 into 0 plus 0 into this. So you will get 0, then 1 into, then consider the second row of the first matrix 1 1 and multiply each column. So 1 into 1 plus 1 into minus 1024. So basically you will get 1 minus 1024. So that's why this is minus 1023. Okay, and then 1 into 0, that is 0, and 1 into 1024. So that's why you will get 1024, right? So what is our answer? 10 minus 1023, 1024. So let's see. Here is our answer, 10 minus 1023 and 1024. Okay, so multiplication of these two matrices are quite easy. You can solve it. Now another question is, we want to find the eigenvalues of a square. That is also quite easy, because we know that eigenvalues of a is 1 and 2. So there is a theorem that if lambda is an eigenvalue of the matrix A, then lambda raised to k is an eigenvalue of a raised to k. Okay, so we know that eigenvalues of a are 1 and 2. Eigenvalues of a are 1 and 2. So the eigenvalues of a square are 1 raised to 2 and 2 raised to 2. So that is 1 and 4. So that's why here the answer, the eigenvalues of a square are 1 and 4. Okay, so this question is complete now. Next question. Question 5c, that t from R4 to R3 with the linear transformation given by t of x1, x2, x3, x4, that is equal to w1, w2, w3, where w1 is equal to 4x1 plus x2 minus 2x3 minus 3x4, w2 is 2x1 plus x2 plus x3 minus 4x4, and w3 is 6x1 minus 9x3 plus 9x4. We want to find the basis for the range and kernel of t. Okay, find basis for the range and kernel of t, and this question asking 4 marks. Here is the solution. The standard basis for R4, that we know that the standard basis for R4 is here is the standard basis for R4 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. Let's try to find the image vector of this corresponding to this standard basis of R4. We know that R4 is a domain of this linear transformation, right? R4 is our domain of this linear transformation. So that's why we want to find the image vector of this 4 vector. So t of 1 0 0 0, that is equal to 1 0 0 0, that is equal to 4 2 6. Okay, 4 2 6. T of 0 1 0 0, that is equal to, put 0 1 0 0, you will get you will get 1 1 0. Okay, put 0 1 0 0 in this w1 w2 w3. So that's why you will get 1 1 and 0. Okay, so you will get 1 1 0. Put t of 0 0 1 0. So you will get minus 2, because only x3 is 1, x1 x2 x4 is 0. So you will get minus 2 1 and minus 9. Okay, so minus 2 1 and minus 9, and then put we want to find t of 0 0 0 1. So only x1 is 1. So put value in this 3 equation, you will get minus 3 minus 4 and 9, minus 3, minus 4 and 9. So now this image vector span the range of T. This image vector span the range of T. So we form a matrix A whose rows are image vectors. Then we row reduce A to echelon form. So here is the matrix A, which is 4, 2, 6. The first row is 4, 2, 6. The second row is 1, 1, 0. The third row is minus 2, 1, minus 9. And the fourth row is minus 3, minus 4 and 9. Okay. Now this matrix, we want to convert this matrix into a row echelon form. So the first process is we multiply fourth row. We multiply fourth row with 1 and add into the first row. So we want to make here 1. So that's why when you take 4 minus 3, you will get 1. So that's why we are taking this process. We multiply fourth row with 1 and add into the first row. So basically just first row minus first row plus fourth row, right, and add into the first row. So 4 minus 3 you will get 1, 2 minus 4 you will get minus 2, and 6 plus 9 you will get 15, right, 15. Another second, third and fourth row are same, 1, 1, 0, minus 2, 1, minus 9, minus 3, minus 4, 9. Okay. Here is the next matrix. We want to convert. Next process, we want to convert this matrix into row echelon form. So that's why now we have leading entry 1. Below that leading entry we want to make 0. So that's why we multiply first row with minus 1 and add into the second row. We multiply first row with 2 and add into the third row, and multiply first row with 3 and add into the fourth row. So you will get below that leading entry 1, you will get 0, 0, 0 here, right. So that is our next target. So that's why we here is the process. See, we multiply first row with minus 1 and add into the second row. So what you will get, 1 minus 1, 0, 1 minus minus 2, 3, and 0 minus 15, minus 15. So 0, 3, minus 15. Now what is next process? We multiply first row with 2 and add into the third row. So that's why 2 minus 2, 0, then minus 4 plus 1, right, minus 4 plus 1, that is minus 3, and 30 minus 9, that is 21. So here you will get 0, minus 3, 21. What is next process? We multiply first row with 3 and add into the fourth row. So when you multiply first row with 3 and add into the fourth row, you will get 0, minus 2 into 3, that is minus 6, minus 4, that is minus 10, and 45, 15 into 3, so that is 45 plus 9, that is 54. So 0, minus 10, 54. Okay. So now you can understand how we get these values. Okay. Next process, we multiply second row with 1 by 3, third row with minus 1 by 3, and fourth row with minus 1 by 2. So that's why you will get first row is same, 1 minus 2, 15. Second row we multiply with, we divided by 3. So that's why you will get 0, 1, minus 5. Next we divided by minus 3, third row. So 0, 1, minus 7, and fourth row we dividing by minus 2. So we will get 0, 5, minus 27. Now this is our leading entry in second row. This is our leading entry. Below that leading entry we want to make 0. So that's why we multiply second row with minus 1 and add into the third row, and we multiply second row with minus 5 and add into the fourth row. So first row is as it is, 1 minus 2, 15. We multiply second row with minus 1 and add into the third row. So that's why second row is also as it is. Third row become, from this matrix you can understand, 1 minus 1, 0, minus 7, minus 5. So minus 7 plus 5, that is minus 2, and second row we multiply with minus 5 and add into the fourth row. So 5 minus 5, that is 0, minus 27 plus 25. 5, because minus 5 into minus 5, that is plus 25. So minus 27 plus 25, that is minus 2. Okay, so here is the matrix 1 minus 2 15, 0 1 minus 5, 0 0 minus 2 and 0 0 minus 2. Third and fourth row are same. So whenever you take whenever you multiply third row with minus 1 and add into the fourth row, the fourth row become 0, and then dividing by minus 2. So you will get in third row you will get 0 0 1. So here is the process. We multiply third row with minus 1 and add into the fourth row, and then we multiply third row with minus 1 by 2. So third row becomes 0 0 1 and fourth row becomes 0 0 0. First and second row are as it is. Now from this matrix you can find, okay, so this what are the non-zero rows? 1 minus 2 15, 0 1 minus 5 and 0 0 1. That are exactly 1 minus 2 15, 0 1 minus 5, 0 0 1. This 3 vector is a basis for the range of T. Okay, and hence the dimension of the range is 3, because we have 3 vectors. Now we want to find the kernel of T, right? To find kernel of T, we take T of x is equal to 0, where x is equal to x1 x2 x3 x4. So this means T of x1 x2 x3 x4, that is equal to 0 0 0. Now what is T of x1 x2 x3 x4? We already have w1 w2 w3, which are the coordinates of the codomain. So here is the w1 equal to 0, you will get w1 is equal to 0, w2 0, w3 0. So you can see here is w1, this is w1 is equal to 0, w2 is equal to 0 and w3 is equal to 0. So here is w1, 4x1 plus x2 minus 2x3 minus 3x4 is equal to 0, 2x1 plus x2 plus x3 minus 4x4 is equal to 0, and 6x1 minus 9x3 plus 9x4 is equal to 0. Now we want to solve these 3 equations, so that's why we use augmented matrix, which is first row is 4 1 minus 2 minus 3, 4 1 minus 2 minus 3. Second row is 2 1 1 minus 4, 2 1 1 minus 4, and the third row is 6 minus 9 9, 6 0 minus 9 9, 6 0 minus 9 9, x1 x2 x3 x4, that is equal to 0 0 0. Now we want to convert this matrix into a row echelon form, so that's why first of all we are interchanging some rows. We are interchanging first and second row, and then first and third row. Okay, so basically this second row in this matrix, the second row become the first row, 2 1 1 minus 4. The first row become second row, 4 1 minus 2 minus 3, and the third row become second row, third row becomes same, 6 0 minus 9 9. Okay, now we multiply first row with minus 2 and add into the second row, and we multiply first row with minus 3 and add into the third row. So that's why you will get, see, whenever you multiply first row with minus 2 and add into the second row, you will get here 0, then minus 1, then minus 4 and minus 3 plus minus 4 into minus 2. So minus 3 plus 8, so 5. So minus 1 minus 4 5. Okay, the second row. Next we multiply first row with minus 3 and add into the third row. So that's why you will get 6 minus 6, here 0, then 0 minus 3 minus 3, minus 9 minus 3 minus 12, and 9 plus 12 21. So here is the third row, 0 minus 3 minus 12 21. Okay, now this is our leading entry. Below that leading entry now we have 0. In second row this is our leading entry. Below that leading entry we want to make 0. So that's why we multiply second row with minus 3 and add into the third row. So multiply second row with minus 3 and add into the third row, you will get minus 1. We multiply second row with minus 3 and add into the third row, minus 3 plus 3 you will get 0, minus 12 plus 12, okay, because minus 12 plus minus 4 into minus 3, so you will get minus 12 plus 12, that is also 0, and 21 minus 5 into 3, that is 15. So 21 minus 15 you will get 6. So the third row become now 0 0 0 6. First and second row are as it is. Okay, now this matrix is into a row echelon form. This is our leading entry in first column. Below that leading entry we have 0. In second row this is our leading entry. Below that leading entry we have 0, right? Now you can see in this matrix, in this row echelon form matrix, we have leading entry are in first column, second column and fourth column. The third column we does not have leading entry, so we are using that one, right? The third column we does not have leading entry, so that's why we can use this one, because this third column is for x3, so that's why we have to suppose x3 is equal to t, right? So hence the rank of the coefficient matrix is 3. Also n is equal to 4, so there is n minus r is equal to 4 minus 3, that is 1. 1 is free variable. From the above matrix you can see, from the first row you will get 2x1 plus x2 plus x3 minus 4x4 is equal to 0. 2x1 plus x2 plus x3 minus 4x4 is equal to 0. Minus x2 minus 4x3 plus 5x4 is equal to 0. Minus x2 plus minus 4x3 plus 5x4 is equal to 0. So whenever you multiply with minus 1, you will get this equation, x2 plus 4x3 minus 5x4 is equal to 0, and the last one is 6x4 is equal to 0. So that's why you will get x4 is equal to 0. Now let x3 is equal to t. Okay, let x3 is equal to t. So put this value x3 and x4. X4 is already 0, x3 is t. So x2 is equal to minus 4t. From this equation x2 is equal to minus 4t. Now put this two value x3 and x2 in this first equation.